Hey guys, today what we're going to be doing is 6.4 modeling in geometric sequences, so make sure you look for those particular notes. Whenever you're talking about geometric sequences, all that means is that you are looking for a number that you're multiplying each time in order to get to the next term. So in order to go from 2 to 4, 4 to 8, 8 to 16, 16 to 32, all you're doing every single time is multiplying by 2. So that's what we're going to be focusing on today. I'm going to tell you some other formulas that we have that we'll be working on tomorrow, but for today we're going to be focusing on how do you get to the next number. Now, the first formula that I'm going to talk about is your recursive formula. Your recursive formula is stated as a to the nth, that's your nth term, is equal to r, which is your common ratio. In other words, the number that you're multiplying by each time, times your previous term. Your previous term is always going to be a to the n minus 1, okay? So in this particular case, and this is the easiest way for you to find out your common ratio, here I have 8, 12, 18, 27, and then 40.5. In order to find out what your common ratio will be, is just by taking your numbers and dividing them. So 12 divided by 8, when you reduce it down, you get 3 over 2. 18 over 12, 3 over 2. 27 over 18, 3 over 2, and 40.5 over 27 is 3 over 2. So because all of them reduce down to 3 over 2, that means that my common ratio has to be 3 over 2. So if I asked you to write a recursive formula, all you would do is put a to the nth is equal to 3 over 2 times your previous term, which is always going to be a to the n minus 1. Where a to the 1 is equal to 8, because remember our first term is 8. So you guys should remember this stuff from us doing it before. Now, the second formula that we have is your explicit formula. Explicit formula just means that we're going to change it just a little bit. We're going to use the first term, our common ratio, and then n minus 1. So again, I already know that my first term is going to be 8 because we already found that out in the first one. I know my common ratio is 3 over 2 because, again, we found that in the first one when we looked at these numbers. Now, if they ask me to find the 10th term, literally all we're going to do is use those two things that we already found out in order to put it into my formula. So I know a to the 10, and I know it's 10 because I'm looking for the 10th term, is going to be equal to a1, which is 8, times the ratio, raised to 10 minus 1. Why 10? Again, because I'm looking for the 10th term. 10 minus 1 gives me 9, so that's why I have a 9 here. And then, of course, we want to do this exactly how we did it before in the other videos. Remember I told you, in order to do this, all you need to do is hit 3 divided by 2, because that's what 3 over 2 means. You'll hit equals, hit the function button, and then hit 9. And this will give you 3 over 2 to the 9th power. But remember, again, I need to multiply by 8. So times 8. And that gives me the answer that I have. Keep in mind that that 4 turns into a 5 because the 6 is 5 or greater. Now, let's start doing the examples. Remember again, what I said is all we're going to do is find out what the common ratio will be. So for each one of these, all I need to do is take my calculator and find out what my common ratio will be. So you're going to start with your second number and then hit divided by 3. So in order to go from 3 to 4.5, I know it has a ratio of 1.5. Again, if I want to go from 6 divided by 4.5, I get an answer of 1.3. 7.5 divided by 6, I get 1.25. 9 divided by 7.5 gives me 1.2. Notice none of my numbers are the same. Because none of my numbers are the same, that automatically means that this has to be an arithmetic sequence. In other words, a number that I'm adding each time in order to get my answer. So going from 4.5 minus 3 gives me 1.5. 6 minus 4.5 gives me 1.5. 7.5 minus 6 gives me 1.5. And 9 minus 7.5 gives me 1.5. So in order to identify whether it is arithmetic or geometric, you need to make sure that all you are doing is you're seeing if first you could divide in order to get it. If you can divide and you get the same number, then you know it's geometric. If not, then it has to be arithmetic. So my answer for this one would be arithmetic. Moving on to the next one. I have 75 divided by 1. You guys know that. That's 75. 149 divided by 75. Let me do that again. 149 divided by 75 gives me 1.99. Automatically, I know that this cannot be what I'm doing. So I'm going to go back through. 75 minus 1 gives me 74. 149 minus 75, 74. 223 minus 149, 74. And 297 minus 223, 74. So again, this is arithmetic. All right, jumping to the next one. 2.2 divided by 1, I know, is 2.2. 4.84 divided by 2.2, I get 2.2. So I want to keep on going because now I've gotten the same number. 10.648 divided by 4.84, again, is 2.2. So because remember, I'm dividing each time, I'm getting the same answer. That means this one has to be geometric. All right, next one. I have 905 divided by 905. I know that's going to be 1. 905 divided by 905, I know that's going to be 1. But if you look at it, 905 minus 905 is going to give me 0. 905 minus 905 again is going to give me 0. So in this particular case, this is both geometric and arithmetic because of the fact that it works for both cases. So in this case, I would put both. All right, next one. 16 divided by 9 gives me 1.8. 25 divided by 16 gives me 1.5. I could, 1.6 actually. I could stop there because I know that these two numbers aren't the same, so automatically it is not going to be geometric. So let's try subtracting. 16 minus 9 gives me 7. 25 minus 16, it doesn't give me 7, it gives me 9. So notice for this one, neither way worked. So whenever you run into a situation like that, the answer is neither. because it is not geometric and it is not arithmetic. In this particular case, you should know these special numbers. This is 9, 16, 25, and 36. If you remember, these are perfect squares. That means this has to be an exponential function. That's why it's different. All right, sometimes you'll run into word problems. It works the same exact way though. Here you have, while sorting beads, Bob put 66 beads first, so I know my first number is 66. In the first jar, 52 in the second jar, 38 in the third jar, and 24 in the fourth jar. So now all I need to do is figure out if it's geometric or arithmetic. So 52 divided by 66 gives me 0.8. 38 divided by 52 gives me 0.7. Right now I could stop there because I know it's not going to be geometric. So now I need to see if it's arithmetic. So 52 minus 66 gives me negative 14. I have to get negative 14 for the next one in order to make sure it's working out. So 38 minus 52 gives me 14. So it's still working. Let's see if it works for the last one. 24 minus 38 gives me negative 14. So this one is going to be arithmetic. All right, that's basically it, what you guys are going to be doing for your IXL lesson for today. When you go in, make sure you look for identifying arithmetic or geometric sequences. All you're going to do is determine which one it is. If it's arithmetic or geometric, remember arithmetic means that you're adding or subtracting. Geometric means that you're multiplying or dividing, and I showed you how to see which one is which. And you might come across one that is neither. So please make sure that you go through and get this done. Have a good day, guys. Bye.